Hi everyone, welcome back to another video of CambiHub, and my name is Pranay Arora, and today we are going to be covering chapter 3 hardware, which is considered to be the most, I don't know why it is considered to be the most difficult chapter by most of the students, but today we are going to break that loop, break that vicious cycle of people thinking every year that this is the most difficult chapter. And yeah, there will be few things before we start the video. First is you need to join a WhatsApp community for resources, doubt clearance, and everything. We do organize free sessions. We also offer tuitions. We also offer paid sessions. So for the community, you'll find the link in the description. Secondly, yeah, we also post all of our notes, resources, worksheets there. All of the past papers in our folders, right? You can find it there on our community. The link is down below. Also, we will be covering chapter 3 today, and since chapter 3 is a huge chapter, right, we'll try to keep the video less than 1 hour because it's a recapitulation video. So recapitulation means you already know the chapter, you already have studied the chapter. Even though you haven't studied, you can watch the video, but to get an in-depth understanding, I recommend attend a class at school, or just pause the video right now and spend half an hour, 40 minutes just going flipping the pages. Whatever you don't know, just read through it, and then I'll deepen your understanding by clearing all of the confusion and all of the concepts. So starting with one of the first concepts, hardware, right? Whenever we talk about hardware, what do you understand by hardware, right? See, whenever I talk about a computer system, right, I'll name it as CS. Whenever I talk about a computer system is divided into two portions, right? One is called software and the other is called hardware, right? So in layman terms, hardware is something which is tangible, right? Tangible in the sense we can touch hardware, whereas software is something which is, you can call it virtual, right? These are the two parts of the system through which our system runs, and that's why we'll be studying hardware first of all, and then in the next chapter we'll be studying software. Why hardware? Because hardware is the most fundamental part of your system. Without the hardware, your system won't be able to function, and I hope that's pretty, that's the common sense here, right? So that's why we'll be studying hardware. Before we start, one clear thing, all of these images and the content has been taken by Cambridge University Press, IGCSE O-Level Computer Science course book, and also the Hodder Education one, the details of which are written here, and you'll also find a link in the description to buy those books, right? Hodder one is an awesome source because it has a lot of, it's used by most of the schools. Even I used it to clear my IGCSEs. I got an A-star in computer science, and it's purely because of that book, I guess, because it has everything at one place. However, when you want to revise stuff, or when you want to get a crisp idea of what the chapter says in a short format and brief, you will find that in the CUP. And CUP is Cambridge University Press book. The green colored one is also an important book. So I recommend you buying both the books, or if you can find a PDF, you can do that. You can buy a PDF also online. You can purchase one and buy a PDF of the other. Coming back to the chapter, we are talking about hardware. So whenever we talk about the hardware, the first thing that should come into our mind is the central processing unit, or we call it the CPU, right? Why? Because CPU is known as the processor and or the microprocessor, you can say, right? CPU is the one that processes all of the information. CPU is called the brain of the computers. We did that in junior grades, right? So CPU is actually called the brain of the computer system because it is the one which manages all of the tasks, everything that the computer does, right? All of the processes is managed by the CPU. Now, there are few components of the CPU. The CPU contains an ALU, which is arithmetic and logical unit, control unit, registers, and buses. What are all of them? We'll just give a quick discussion to them. Just before that, we'll just understand what the von Neumann architecture is. Right. So this portion that you can see here is the von Neumann architecture. Right. Okay. So we all know that our everything in the computer system is in an integrated circuit, which is called the motherboard, right? If you have a laptop, you can open the back screws, the screws at the back of it, and you'll find an integrated circuit that's called the motherboard, right? However, von Neumann architecture that we're studying right now is an architecture which is created by von Neumann. That's why it's named as von Neumann architecture. Pretty self-explanatory. What is the von Neumann architecture? So von Neumann was a person who first time brought in this thought of CPU. right? Before this, we didn't have a central processing unit. Nobody thought that there could be a core in between, a core mind in between, which can manage all of the other processes, right? This is the first thing. Second, the CPU was able to access the memory directly, right? The access to the memory, the memory for the system was just beside it. So there was quick access to the memory. Computer memories could store programs as well as data. Earlier, memory was only used for programs, but now it could also store data, right? And stored programs were made up of instructions which can be executed in sequential order. Obviously, if I give you an instruction, okay, create a graph on this topic. So you will process each information in a sequential order, right? You will first think, okay, what the graph needs to be on. How would I plan my graph? Would it be a bar graph or a linear curve or a graph or stuff like that, right? So you're also moving in a sequential order. Similarly, the von Neumann architecture was based on instructions that are executed that move in a sequential order, right? Now, talking about all of these four components, ALU, CU, registers, and the buses, let's start with ALU. So ALU is called the arithmetic and logical unit, right? So if I try to create a mini CPU version here, right, this is my CPU, I have my ALU, I have my CU, and I have my registers. Now you would say, where are the buses? I'll just tell you where the buses are. First, let's talk about the ALU. So ALU is the arithmetic and logical unit. Arithmetic and logical unit is responsible, as the name says, for all of the arithmetic processes. What are the arithmetic processes? Plus, minus, divide, multiply, all of these arithmetic processes ALU is responsible for all of them, right? CU, whereas the control unit is responsible for synchronizing all of the data that is there, right? Control unit, that's why it's called the control unit. So all of the instructions, when they are processed in our computer system, right, they are finally decoded by CPU. So the control unit. What does the control unit send? The control unit send timing signals, right? What does the control unit send? A control unit sends signals around the system, right? And that is what the job of control unit is, right? It will tell what needs to be done, right? So what is the difference between ALU and CU? ALU is responsible for all of the arithmetic operations, whereas the control unit is responsible for timing signals or to synchronize the data, right? Okay, coming to registers. When I say, okay, please fetch me a glass of water, and I say you register that information, what do I mean by that? You kind of stored it somewhere, but would that information remain lifelong? Like for your whole life, would you remember that, on like maybe 24th October 20 blah 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 some date, Pranay Arora asked me to bring a glass of water. You won't remember that. That's just temporary. You'll help me, you'll bring a glass of water, you'll hand it over to me, and then you'll forget about it, right? So you're registering temporarily. So registers are temporary memory, right? See, whenever I ask you to do any instruction or any operation, you are also storing it in your brain somewhere temporarily, right? Similarly, in computer systems, everything is stored in binary. That we did in chapter 1, no? So everything is stored in binary. But however, it is never it is stored in binary, but it is, a computer system cannot work without storing anything, right? It cannot remember anything without storing it. So it needs to store it somewhere. So whenever, we'll understand how the CPU works, how the fetch decode execute cycle works fully, right? But before that, all of the results of the calculations and stuff are stored in the register. The computer stores it in the register, right? Coming to the last component that we have to discuss, buses. Okay, it's not visible. Let me write it here. Buses. What is the role of a bus, right? What is the role of your school bus? If you're a high school goer, what is the role of your school bus, right? You sit inside the bus transports you from your location A, your home, to the school, right? That's the role of a bus, right? Similarly, in computer system, bus is responsible to transport information, to transport data, right? To transport all of the signals, right? And there are three types of buses that we'll discuss. We'll just discuss that, right? Before that, let's discuss a very interesting cycle called the fetch decode execute cycle, called the fetch FDE, or even in your past papers you'll see F-E. What is F-E? What is this fetch decode execute cycle? Let's explain it. Let me explain it to you with a very interesting idea, right? Let's say I gave you a task to bring me a glass of water. This is the task I gave you, right? This is your task, right? The first thing you did was you heard me, right? Listening, right? You are taking in information, you are hearing me. Second thing you did was your brain processed, right? Your brain processed whatever, whatever needs to be done. Your brain is thinking, okay, I need to get a glass of water. What is the location of the kitchen? What is the location of the glass? What is the location of the dispensers through which I need to take the water, right? What path I would take? All of this is being processed by your brain. And the final step you'll do is executing it. What do I mean by execution? You'll take the water, come to me and give it to me. Right? That's in simple terms what execution of your task means. So you followed a 3-step process, right? What did you do? You fetched the data. You first input the data, you fetched the data, you took in the data, you processed the data, right? You decoded it in technical terms, you processed the data, and then you executed it, right? This is the fetch, decode, execute cycle, right? So fetch stage, this is the stage where the instruction is taken by the CPU. Decode is the stage where it is processed by the CPU, and execute is the stage when the CPU actually performs that, when the instruction is actually executed, or whatever the necessary problem is, or whatever the necessary steps are to be taken is taken by the system, right? I hope the fetch, decode, execute cycle is clear to you. Let's talk about few of the buses. So I told you there are 3 buses, right? We have control bus, we have data bus, we have address bus. We have control bus, data bus, and address bus, right? These are the 3 types of buses, right? These are the 3 types of buses that we have in our syllabus. What do these buses mean? What do these buses do? Right? First, we have the control bus. The role of control bus is to take in timing signals. Just try to remember, we just discussed something about timing signals somewhere. We discussed it in the control unit, right? The control unit is responsible to carry out the timing signals. But who will actually transport that timing signal to the locations? That will be done by the control bus. The data bus is responsible to transfer data, right? Because it is pretty self-explanatory. Its name says that it will transport data. The address bus is going to transport address. The address bus is going to transport the address of the data. This will get more clear. I'm just giving you introduction to each and everything. Then I'll show you the whole process of fetch, decode, execute cycle in detail. How does the computer actually do it? And then you'll get a better understanding of it. Right? I hope this is clear. Now I'll give you one slight homework. Just pause the video right now. Go to Google and search which one of these buses are unidirectional and which one of these buses are bidirectional. Right? Suppose you just go to the comment box, search and type your answer there. I will also pin a comment which is correct, which is the correct answer, so that you get an idea. What I mean by unidirectional, bidirectional? Unidirectional means the data can only be transferred from one place to another in one direction. It cannot come back, right? If it has been transferred from point A to point B, it cannot come back from point B to point A. Data can only transfer one way. Whereas bidirectional means it can go both ways. So your role is to go on Google and search, Google or whatever, Bing, whatever thing you use, search engine you use, just go there and search which one of these buses is unidirectional and which one of them are bidirectional. Just go and comment in the comment box. I'll pin the right comment so that you can check your answer. Coming on to the registers. What are these registers? Right? I have few certain registers here. The first register is the current instruction register. Right? What is the role of this register? Whatever the current instruction that is being processed by the CPU is stored here temporarily until the instruction is resolved, right? Or like it's executed. So current instruction is responsible to store the current instruction that is being decoded and executed. What is the role of accumulator? Accumulator is responsible to save all of the, I told you that ALU right? ALU does all of the arithmetic and logical calculations. So where would the computer save these calculations? Obviously in a register, and that register is called the accumulator. It temporarily holds the data of the accumulator. We have the MAR, memory address register, which stores the data of the, which stores the address of the instruction, and which is the MAR and address bus are connected. Why? Because MAR will store the address and address bus will carry it to MAR, right? MDR is memory data register. As the name says, right, it will be transporting. It is responsible to transport data. And who would be, what bus would be connected to MDR? Data bus. Why? Because we are transporting data. So data bus is responsible to bring the data to MDR, and MDR is responsible to store it temporarily. What is program counter? Program counter keeps a track of how many instructions are being processed, right? So for example, if one instruction is being processed right now, program counter's value will be 1. Now suppose one instruction has been processed. Now the next instruction is there. So program counter holds the address of the next instruction, and then it gets incremented. So it keeps a track. It will get 2, 3, 4, 5. Its value will keep on changing. It will keep a track of how many instructions are being processed, right? It will get incremented. Incremented means program counter is program counter plus 1. What does that mean? Every time a new instruction comes, program counter's value will get plus 1. This is the meaning of incrementation, right? This is the meaning of incrementation, right? Now coming on to the fetch, decode, execute cycle, this data that I've taken is from Computer Science GCSE Guru. A wonderful job they have done, right? The link is also there. I'll try, I think, including the link in the description or the comment, right? It's such a good link because they have given you two things here, right? They are showing you, again, you can go to the link and refer to their notes. Their notes are really crisp, they are really short. And what they've done is, so this whole fetch, decode, execute cycle, the whole, mess that I've created, this is the whole process arranged in order that we'll discuss right now. What they've done is they have arranged it in two ways. This is the cycle and this is the simplified version of it. So if they ask you the fetch, decode, execute cycle for a 7 marker, you can write in this way. Or if they ask you for a 5 marker or a 4 marker in a simplified way, you can write this section, right? So let's discuss what the fetch, decode, execute cycle is, right? Firstly, whenever an instruction is there, program counter will contain the address of the memory location that has the next instruction that has to be fetched. For example, the next instruction is coming from memory location A. Program counter will hold that data of the memory location. It will hold that address of the memory location. It will know where that memory location is, right? From the program counter, this address is then carried to the MAR, memory address register, using the address bus. It's a very complicated process. There is no explanation to it. I'm trying my best to explain it to you. Just please bear with me. I'll create a chart so that you can easily remember, right? Then this instruction, right, the data, the contents is copied from the MAR and transferred to the MDR using the data bus, right? Then the contents of this current instruction is transferred to the current instruction register. Then the value of the PC is incremented, program counter is incremented by 1 so that it knows that the next instruction is coming. And then the instruction is finally solved, it is processed, it is decoded. By whom? By the control unit. How would the control unit do it? By timing signals. And who would do that? Control bus will carry those signals, and then the process is in loop. So what happened here? Let's simplify the process so that we can understand it. First, the instruction was the address of the memory location's address was there with the program counter. The program counter sent the address. What did it send? It sent the address to the memory address register. It sent the address to the memory address registered. Then it sent the contents of this data to the memory data register. Okay, who brought it to the memory address register? Address bus did that, right? Who brought it to the memory address register? Address bus did that. Who brought it to the memory data register? Data bus did that, right? So from program counter to memory address register to MDR, then its contents went to CIR, current instruction register, right? Current instruction register. From current instruction register, it went to the, okay. From the current instruction register, the program counters value, let me just check. Right, from the current instruction register, the program counters value incremented. It increased by 1. It got, the keyword here is it got incremented. Right? We got the CambiHub logo in the in between. Right, it got incremented. Then it got decoded. It got solved. It got processed by the control unit. How did the control unit do that? By sending out timing signals. And who did that? Who carried those timing signals? The control bus. Then at the end, the process is at loop. It's repeated. Right? I hope now the process is simplified. Right? And if you want more clarification, you can read this portion of it. Please do visit Computer Science GCSE Guru. Not a sponsor, just giving them the right credits. Just giving them the credits that they deserve. Okay. The answer to the question that I asked has been shared here. Data bus is bidirectional, address bus is unidirectional, and control bus is bidirectional. Right? The timing signals are sent by control unit. Right? This is a recapitulation. Coming to something called the clock speed. Right, so I told you that the control units or the system synchronizes all of the data by sending out timing signals. Who does that? The clock does that. Right, what is clock speed? So clock speed can be defined as number of fetch, decode, execute cycles processed in 1 second. Right, so number of fetch, decode, execute cycles your computer can process in a second is called the clock speed, right? And clock speed is always measured in gigahertz, right? So 3.5, if your systems, another homework, if you have a laptop, you can Google your laptop's clock speed and you'll get to know how many fetch, decode, execute cycles your laptop CPU can process in 1 second, right? So 3.5 GHz means 3.5 billion clock processes in 1 second, right? I hope clock speed and clock is clear to you. So who is responsible? Clock is responsible, right? Taking the help of control unit using the timing signals, and number of fetch, decode, execute cycles in 1 second is the clock speed. It is measured in gigahertz. 3.5 gigahertz means 3.5 billion clock processes in 1 second. Right. Now there is something called an instruction set. Right? Instruction set is a set of operations which is decoded in a sequence, which is processed in a order, in a chronological order, stepwise, sequence wise, right? And this instruction set has two parts, operand and opcode. It has two parts, opcode and operand. What does opcode do? Opcode informs the CPU what operation needs to be done, and operand is the data where the needs on which it tells the CPU what data on which it needs to be acted on and in what register, in what memory. So basically this is telling what, this is answering the question what, and this is answering the question how or where, right? This is answering the question what, this is answering the question how, where. Rest you will study this in detail in ASNA level in 11th 12th grade. I mean, that's according to the Indian system. I don't know about your country, but rest you will study at that time. So let's go to the next topic. The next topic that we have is called the embedded system. What do we mean by embedded? Right? An embedded system is an integrated circuit, right? An embedded system is an integrated circuit. It's a combination of software and hardware which is designed to carry out a single task or a specific set of function, right? Where would you find these embedded systems? Washing machines, TV, TV remote, microphone, right? What else? Automated mixers, right? Mouse, toy car, right? You can see the examples now. Toy car, right? You can just click a screenshot if you want, right? What are these embedded systems? They are a very small system. See, when I talk about a washing machine does not need a proper system, or a proper processor and stuff like a phone has, right? Like a phone has, because phone does a lot of complex, tasks as compared to washing machine. So hence we created the concept of embedded system, where only one task can be done, right? And there is a microprocessor. What is micro? Micro means small. So a mini processor, a mini circuit, a cute circuit which can only do one task, right? System on chips. So it has three things. It has microcontrollers. Microcontrollers are basically the, that mini controllers which include your storage devices and stuff that control the system. Microprocessor is obviously a mini processor, and system on chip is basically an integrated circuit, right? However, since the circuit is so small, there are few advantages and disadvantages. Advantages will be it is easy to use interface. Obviously, it does not have, a whole Android or iOS operating system like our phone, or maybe Windows and Mac OS like a laptop, right? It is smaller in size, so it can be fitted in anywhere. It is dedicated to one task, so it will be efficient in that. And it is usually a component of a larger system. It is a part of a larger system, usually, right? However, there are disadvantages. It is difficult to update or fix errors. Why? Because it is so small. If I keep on need to do operations in that very small circuit, how would I be able to do it? Right? It's pretty difficult for me to do that. So it is difficult to update or fix any errors since the circuit is so small. It requires less power, right? However, once used, it needs to be discarded. It cannot be renewed because it is so small. It's just difficult to repair it or do work on it, right? Let's understand the input and output devices now. Starting with the input devices, the first thing your book explains is barcodes and QR codes. What does a barcode look like? Like this, right? And then it has there's an ISBN number 1234678210223, right? What do these QR code and barcodes hold? They hold an information. They hold information, right? What does barcode do? See, there is a combination of black lines and white lines, black lines and white lines, black lines and white lines. There is alternate combinations of them, right? So where is barcode used? In supermarkets, right? Whatever products we buy, they scan the thing and it's quickly done, right? Because barcode holds the information of that product, and they can, easily see it in their system and they scan it. So how does a barcode work? There is a red laser. There's a red laser which is reflected onto it, right? The black lines, they absorb the red laser, whereas the white lines, they reflect the laser. So using these patterns of reflections and absorption, right, whatever the amount of patterns, the computer recognizes that, and that's how a barcode is read. How does a QR code look like? Something like, right, with a spherical patterns, right? They also work using, in a similar way, but QR codes are generally, processed by the AI of a phone. They recognize the patterns and stuff, right? I hope that this concept is clear. Let's talk about input screens, right? Now there are three types of screens that we'll study, which is, first screen is a capacitive screen, a capacitive touch screen, right? So most common use type of screen in mobile phones is a capacitive screen. Right? How does a capacitive screen work? Suppose this is a mobile phone. A capacitive screen has an electric field, right? Now, since our body also works using electricity, we always have an electrical field around our finger. Whenever we touch this electrical field using our finger, it gets disrupted. It gets disrupted. So already there was an electrical field, but there's an alternate electrical, charge that my finger holds and I'm touching it. So it gets disrupted. Right? And that is how the computer exactly calculates the x, y coordinate of wherever you have touched on the screen. That's how capacitive screen work. How does infrared screen works? So infrared screen, they have, on one side they have reflectors. On one side they have sensors, right? On a side they have reflectors, and on one side they have sensors. How would this work? So these reflectors, they reflect infrared radiation. What is infrared radiation? Heat, in other terms. So our body also has heat. Whenever we touch this heat, right? Whenever we touch this heat, obviously this infrared field will also get disrupted, and these sensors are going to catch wherever I have touched. And that's how my CPU calculates, or my computer calculates where I have touched the screen. Talking about resistive screen has two layers. It has two layers generally, right? So how does a resistive screen work? So see, since it has two layers, there's going to be a gap between both of the layers. There's going to be a, let's change the color, let's have fun with the color. Okay, no, never mind, too flashy to use to explain a concept, right? So they'll have a small space between them, right? In the two screens, the resistive screen will have a small space between them. What when the user will do, when the user will press the screen from this angle, right? When I press the screen hard, they get joint. The upper screen goes down and they get joint. When they're joint, the circuit is completed. And when the circuit is completed, the computer calculates, okay, this is the point where the user has touched the resistive screen. Right? I hope the screens are clear. Sources again, Hodder Education book. Right? Coming to the next input devices, which are called sensors. Sensors are the input devices which read or measure physical properties from their surroundings. Obviously, what is a sensor? That senses the surrounding, gathers information from the surroundings. Now, there are different types of sensors that you should know. Your book has a whole list. I'll be going through most important ones. Right? First we have is a proximity sensor or motion sensor. So in cars, whenever, for example, the reverse example could be when the car reverses, there's a beep, right? Suppose this is the wall, and when the car comes back, the beep, then the beep is at a normal speed, and then the beep gets faster. So it's like beep, 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 beep. Why does that happen? Because there's proximity or infrared sensor that senses the wall. Proximity or infrared sensors. What does motion sensor do? Motion sensor senses motion. What does light sensor do? Light sensor is used in light bulbs. Motion sensor is used in light bulbs, automated light. So whenever I come, the light gets on, right? Why? Because the light sensor sensed motion, right? Light sensor basically senses the amount of light. Moisture or humidity sensor obviously will sense the humidity, right? pH sensor senses the pH level. If you are a chemistry student, you would know it. We also have a flow sensor, which senses at what amount the water or the liquid is flowing, right? I hope this is clear. Now in the paper, they ask this a lot. They will ask you the process of how sensors and microprocessors work. We'll discuss this later in chapter 6. So if you want to understand it, please watch the chapter 6 video because it is relevant to explain this process in chapter 6. So please watch the chapter 6 video. As of now, I'm skipping it. Coming on to the memory. So you need to understand the difference between memory and storage. So I told you, whenever I'm talking about computer systems, right, they need to store all of the data that they process somewhere, right, at a temporary storage, like we did registers, right? However, we as humans, we also use other storage types, right, to store our files, music, sound, media. We use pen drives, we use hard drives, right? So what's the difference between memory and storage? Memory is a term basically given to memory used by the computer, right? Memory is generally a term which is given to devices that are used by the computer. So whenever the computer, registers are an example of memory, or RAM, which we'll just study now, ROM, are an example of memory, right? So memory is a term which is generally given to the storage that the computer itself uses. We humans have no role in that. Computer automatically does that. Whereas storage is something which is used by us, used by the user, used by humans, used by us, right? So all of these pen drives, hard drives, our internal storage where we store files, data and stuff, is an example of storage. Generally, I'm just giving you a general difference between them. So let's study about primary memory. See, primary memory is obviously in the CPU. It contains three things, RAM, ROM and cache memory, RAM, ROM, and cache memory, right? What is RAM? What's the difference between them? So RAM is volatile, whereas ROM is a non-volatile memory. So RAM is a temporary memory. Suppose I open PowerPoint. Suppose I open Microsoft Word. I open Google Chrome. Everything is temporarily stored in the RAM. Everything is temporarily stored in the RAM. And hence, when you open a lot of applications, a lot of Chrome tabs, your RAM starts getting full and your computer starts getting slower. Or if you have less RAM in your computer system, it works slower because anything that you are opening is temporarily getting stored in RAM. Any currently used data, currently used soft application, currently used program, currently used instruction, everything is stored in RAM temporarily, right? ROM stores permanent data. Permanent data as in the fonts of the computer system, or there's a basic input output device, BIOS, or the kernel of the system. This is stored by the ROM. So ROM stores permanent data which cannot be deleted. Right? Once the manufacturer has set the data inside the ROM, it cannot be changed. It cannot be changed at all. However, there are different types of ROM that you'll study in ASNA level. So let's not go into that. Cache. So cache is a memory which is just beside the CPU. The CPU uses it to store instructions. It is a quick access memory. It is quick access memory. If somebody asks, cache uses SRAM technology. It is a quick access memory, right, which the CPU uses to store data and take out quickly, right? I hope the RAM ROM thing is clear to you. The cache is also clear to you, right? And this primary memory is directly accessed by the CPU. If CPU is here, the memory will be here, so that there's less transportation time, and CPU, if it would have been far away, that there would be a wire which would slow down the task, right? Okay, coming on to secondary storage devices. Secondary storage devices are the devices that we use, right? It is not directly accessed by the CPU, right? They are non-volatile, they're non-volatile devices, and they can be external or internal, right? Obviously, the internal storage could be HDD. Examples could be HDD and SSD for internal storage. Internal storage is where you store your files. When you open your files app, you get that desktop documents, downloads and stuff. That is your internal storage, where your operating system is stored, where Windows is stored, Android is stored, Mac OS is stored, Linux is stored, Ubuntu is stored, iOS, whatever system you use, that is stored there. Or your personal files, that is internal. What is external? Blu-ray discs, DVD discs, memory stick, or a USB, right? Those are external peripheral devices that I can connect into my system, right? I hope this internal external thing is clear. Now RAM has two types, DRAM and SRAM. We won't go into detail because this is not there at IGCSE. This is there at AS level, right? So we'll study when you pass your IGCSEs basically, and you continue with Cambridge. RAM. Okay, this is a very easy difference between them. Whatever I've just told, it's a recapitulation of it. If they ask you the difference in the exam, you can pause the video, read it out carefully. If you have any doubts, ask in the comments. I'll be happy to answer it. Moving on, let's talk about HDDs. Whenever I talk about magnetic storage, right, I'm talking about hard disk drives, which are HDDs, right? How does an HDD work? HDD is a magnetic storage, so it includes magnets. So I have a spiral track, like I have a spinning thing like this, and I have concentric tracks. And there's a read-write head. So whenever all of these disks are spinning at a constant speed, and whenever they spin and go through this read-write head, this read-write head stores the data on these disks, right? It stores the data on these disks. So there'll be a read-write head here too. There'll be a read-write head here also, right? This is how magnetic storage work. All of these are magnets, right? And all of these are moving parts. So if your HDD falls down, or if your laptop falls down and you have an HDD in it, HDD might stop working, or your data might get deleted, or it might get corrupted. Why? Because HDD has moving parts. So it can mess up with the system if it falls down, right? And also, since it is rotating, it will generate friction. Friction generates heat. So it's going to get warm. Right? So this is how the magnetic storage works. However, one problem that could be done is the data can be scattered, right? It can be stored anywhere, which makes our system slow. This is called fragmentation of data. It is called fragmentation of data. It can fragmentize your, it can create small parts. Fragments mean small parts. So your data can get scattered, which can make your system slow. So we have softwares called defragmentation, which organizes your data at one place, or which sorts your data. Defragmentation software. What is defragmentation? Opposite of fragmentation, right? So this is all about HDDs that you need to know. What is SSD? SSD is a different version of it's an advanced or a better version of the thing that we just discussed right now. Right? HDDs can have latency, they can have lag. Right? When your system starts lagging or it gets stuck, it has bugs. Not bugs, basically it gets stuck or it lags. That's called latency. And this defragmentation sorting part we discussed, right? However, we also have this solid state storage. We also have SSD. SSD is faster because it has no moving parts like HDD. Like HDD is having moving parts, it has no moving parts. Right? No moving parts means it will generate less sound. It will not generate heat, no heat. Right? Obviously, because if there are no rotating parts, there'll be no friction. So there'll be no heat. Right? I hope SSD and HDD is clear to everyone. When I talk about sensors, yeah, these are some of the sensors: temperature, light, pH, humidity, moisture level, motion, infrared, accelerometer, proximity. Accelerometer is in cars, which calculates a car's acceleration. Temperature calculates the temperature, right? Okay. Coming to, okay, why SSDs are better, right? All of this information we have just discussed. However, SSDs have a limited life. HDDs have a more lifespan than SSD. However, if HDD falls, it's going to get messed up, right? How does DVDs work? DVDs work using, there are two types of DVDs. There is a Blu-ray disc which uses a blue laser, and we have DVDs which uses a red laser. So you can see these concentric spirals, right? The data gets stored in these concentric spirals, and we have these pits and lands. This gray portion is called the lands. This white portion is called the pits, where your data is stored, right? A DVD uses two polycarbonate layers, right? You just need to know that there are two polycarbonate layers. The laser will read layer 1 and then the laser will read layer 2. Right? This is a process called dual layering which DVD uses. Right? That's it. That's all you need to know about disks. Right? That's all you need to know about disks, memory, storage devices, output devices, right? Printers, printers and all of these other projectors things have been removed from the syllabus. They're not asked anymore, so you can skip them. However, if you still want to read it, just in case if anything comes about it, you can do, but then otherwise it has been skipped, it has been deleted. That's what teachers say. Now, what is virtual memory? I told you that the RAM stores anything that is currently being run or that is currently being processed. RAM stores anything that is currently being run in the system. However, if the RAM gets full, where will it go now? We have a solution for that, which is called virtual memory. Right? When the RAM is full, what it will do is your internal storage, where you store your files, data, music, all of that, it will take a small part of it and convert it to a temporary RAM. It converted to a virtual RAM. So all of the data that is not needed in the RAM right now, it will get stored here. Right? Whenever there's a data at priority, it will come out of this virtual RAM and come to the actual RAM. Right? I hope this is clear. You can pause the video to read more about it. Right? Coming to cloud storage. What is cloud storage? Cloud storage is when the data is stored on cloud, not on clouds, actual clouds, but I hope you have used Google Drive. You have used iCloud. You have used OneDrive, Dropbox. What else? There are, a lot of examples. There are a lot of examples. We have Google Drive, iCloud, OneDrive, Dropbox. We have a lot of them. A lot of examples. What are these? So they have servers. Servers are large storage locations, right? For example, Google has them in the US. However, even if you are in India and you create an account on Google Drive, you can store your data in their servers and access it anytime. Access it anytime you want. You just need to have internet connection, right? If you don't have internet connection, then obviously you won't be able to access it. However, you can access your data at any time, right? So you're not storing your data at a physical computer location. You're storing it at cloud storage. You're storing it at, virtual space, right? However, one issue with this is you need to build trust on the company that you are storing your data, right? For example, there's a cheap XYZ company that also stores the data now in their servers. However, you cannot trust that company. What if their servers, they're using it to sell your data to someone else? So this is the drawback of cloud storage, and that's what cloud storage is at a recapitulation. Benefits and drawbacks, you can pause the video, and if you want to read it, whatever I've discussed is included this. Another thing is, suppose you are storing your data at some XYZ company and the server fails, your data will get deleted, right? That's an issue. Okay. There are three types of clouds. Public cloud is access to everyone. Private cloud is a personal space, and hybrid cloud is something which works in both public and private cloud. Talking about MAC address and IP address. So what is MAC address and IP address? Right? Okay. So MAC address is a permanent address. MAC address is stored in hexadecimal. MAC address is a permanent address that is used to identify your system. Who gives you the MAC address? The MAC address is given by the manufacturer. Who gives the MAC address? MAC address is given by the manufacturer. So the manufacturer gives the MAC address, and it's a permanent address which uniquely identifies your system, right? What is an IP address? IP address is something when you connect to the internet, when you connect to the router, your router is responsible to give you an IP address, to assign you an address so that you can be identified on that network, right? So suppose there are computer A, B and C. Each one will have a unique IP address, right? IP address is of two types, static and dynamic. Static is which is fixed IP address. Dynamic is whenever you will connect to the internet to the router, it is going to change. And obviously dynamic IP address is safer because you do not want your IP address to be accessed by a hacker, right? Now, if you want to find what your IP address looks like, Google what is my IP, right? Try Googling this exact phrase and it will just scroll down a bit. It will show you your actual IP address, right? A comparison between IPv4 and IPv6 address. There are two types of IP addresses. One is IPv4 and IPv6. IPv4 is a 32-bit address and IPv6 is a 128-bit address, right? IPv4 is stored in 4 groups. It is stored in 4 groups. So it is stored in groups of 4 numbers, right? And it is separated by a full stop, right? Whereas a IPv6 address has 8 groups. It is stored in 8 groups and it has colons to separate the address, right? Only 4.3 billion unique addresses can be created using an IPv4 address. IPv6 address, infinite amount of address can be created, right? Now, what is the hardware component in your system that allows you to connect to the internet? It is called the NIC. It is called the Network Interface Card. It is called the Network Interface Card, right? Network Interface Card. This is what it looks like. Again, the credit goes to CUP, Cambridge University Press. Again, guys, thank you for watching this video. This is a whole recapitulation of the whole, chapter 3. I know it has, I have covered literally everything, and it has, your brain is you're bongled right now, right? However, if you read the chapter once again now, or you can, watch this videos again and again, right? Or specific parts of the videos again and again, right? Which will help you to understand each and every portion of the chapter. Also, we'll be covering several past papers. We'll be covering topical past papers and full past papers also. But obviously we need time so that we create videos for you, right? Obviously we cannot do everything at one night, right? So we'll take time, we'll create quality content like this. However, if you like the video, then please obviously click on the like button, like, subscribe a channel, and also please refer to the any resources, any doubts, any comment you have, you can ask in the comments. However, if you want a quick response, I'm available on WhatsApp. We are available on WhatsApp as a team. We have a IGCSE community where you'll get the chance to make several friends. We have more than people from more than 20 countries, and we organize both paid and free sessions there. You can access the free ones freely there. We also give you summer programs, classes like Python classes, or like events which are organized by bigger companies, so you can join them so that you can also build your portfolio. So it's a really good community. It's called CambiHub. We are CambiHub. You can go to the description and join the link from there, right? Again, if you have any doubts, do comment. I'll try to answer most of the comments, and we'll be doing past papers of this. We'll be doing enough practice of this, so you do not need to worry about this chapter at all, right? If this video has helped you even 10%, share it with your friends. I'll meet you in the next one. Thank you. This is Pranay signing off from CambiHub. Bye.